Hey everyone, thanks so much for joining another Jakarta Tech Talk session. This week we have Otavio Santana and Rudy DeBoucher who are going to be taking us through their presentation. So Rudy, I'll go ahead and let you get started. And everybody feel free to ask questions throughout the presentation and I will ask them to our two speakers. Thanks.
Okay, thank you, Vanessa. I'm Rudy DeBoucher. I'm working for Payara. I'm doing a bit of developer advocacy, so doing presentations like this. And I'm also working for the service team, the support team, so that customers or anyone else who has questions about Payara, they can come to me and I try to help them as much as possible, of course. So short intro of Otavio.
Oh, hello everybody. It's amazing to be here. My name is Otavio Santana. I'm from Brazil and I'm working for Platformsh.
Okay, what Platformsh is, you will discover in this session, and you can see how you can bring your applications together with Payara and Platformsh to the cloud. So first, what is cloud? Short introduction so that everyone knows what we are talking about and what we mean when we say cloud and cloud native, the other term which is very popular these days. I'll continue with a few words about Payara Micro, what it is, how you can use it, and why it is important for your environment, and what specific features we have in the cloud. And then Otavio takes over and talks about the Platformsh, and of course a demo where you all see those things nicely in action, and it's always a fun and thrilling thing to see if it works or not, but trust us, it will be a fun thing. So cloud, what is exactly cloud? Well, basically it is when you move your applications from your on-premise server to a larger data center, which is maintained by the cloud provider. So it's no longer under your control entirely, but someone else is running the server for you. And you have the hardware and the software. The hardware, like the CPU, like the network configuration, is delivered to you via the network, and you can access it through a GUI, a portal, command line, etc. So some of the responsibilities are also delegated then to that cloud provider. Most of the providers support you with automatic upgrades of the operating system, for instance. There are a few benefits, drawbacks also, but let's focus on the benefits here, because you can do a faster setup. You do not need to order your new server integrated in your data center. Just online, you access it through that portal or command line. You execute a few commands, and a few minutes later, you have your server available for you, specific for you, with the specific CPU and memory requirements that you have defined, and you can start using it. Due to that flexibility, it comes with reduced cost in most of the cases, because you only order what you need. It's faster. It does not take days or weeks to have a new server. It can be instantly. Also important for the case when you have a flexible load. You have a web shop, and during the Christmas holidays, for instance, you have a higher load, then you can easily foresee that for a short time of period, a few weeks, that you have an additional server to cover that higher load. It's also a good thing for your security, because those cloud providers have their security experts. They know what they are doing, so your environment will be probably more secure, more kept up to date than when you are maintaining it yourself. There are different cloud models. On the left, you have the traditional on-premise one, and Otavio made a nice comparison with the pizza as a service, so you can read through what you can expect from the infrastructure as a service, platform as a service, or software as a service. So with the infrastructure as a service, then you only are interested in the hardware itself. So you have that server with the configured amount of CPU and memory, and you can access it via remote shell script, for instance. So that server is available for you, and you are responsible for installing your runtime, your application server, whatever application you need to run, you're responsible for doing that. So that's the infrastructure as a service. That's one of the two common models if you talk about cloud. The platform as a service, which Platformsh is an example. There you not only have the server installed for you, but you also have your server runtime. So for instance, Payara Micro is there for you, and you only need to provide your application, provide your configuration to the database, for instance, but all the rest is done for you. So you don't need to worry anymore about installing the runtime or maintaining the runtime. Another use case is the software as a service, which is for specific cases. For instance, your email service is probably like that. You just configure your email, so the server is somewhere. The software is installed by the provider. Only thing is that you need to do is, for instance, connecting to that service, and you can get started. So there are various degrees of what you need to maintain. There's only the server and the application, and depending on that, they call it something else. There is even more things like a service. You have something like 50 or 60 terms now, which say XYZ as a service. So that's a very popular thing today, all coming with that cloud model, which I was talking about. This is just in text what I said about the platform as a service, that you only have to manage the application itself and the data that you are using. So let's switch to the second topic then. What is cloud native? And there it becomes a bit more undefined, because there are a lot of definitions of what cloud native is. So there are many terms. Some people see other things classified as cloud native than other people, but all of them speak about using that possibilities of that cloud environment. You have that infrastructure or platform as a service. You can access it via scripting. So let's make use of that, and that's one part of the cloud native, which is important. So your DevOps story scenarios changes a lot now, because you can have scripts that not only deploy your application, for instance, but you can have a script which even sets up an entire server. Yeah, so you launch a command and you have a server available at some time later in the time, a few seconds, at maximum a minute, for instance. So the DevOps is definitely a part of that cloud native. If we speak about scripts and DevOps, the next step is, of course, your CI/CD environment, because everything can now be scripted. It can be maintained by something like Jenkins or any other continuous integration and continuous delivery software. Again, a next step, everything is automated and is making use of that scripting in that cloud environment, which is then also part of that cloud native term. If you have an application, you test out an application with multiple integration tests, unit tests, and then you go from test to production. You have to install everything on production before it is available for your customers, of course. A lot of times these days, people are using containers for that, because when properly configured, your container, that your database connection, for instance, is outside of your container image. It's not baked into that image, which is not a good thing. So you can create a container, put that under test. If everything goes fine, you can just put that container into production, and with the correct configuration, everything is set for production. That's also part of that cloud native, and the link between that containers, like the Docker containers, and that cloud native. Other people also tell about microservices and cloud native. Microservices, which I come in a minute more in detail, are also named together with that cloud native because of all that automation, which is easier to do with smaller things, not a big application, a mastodon, which you try to put in production every 6 months or so, but you do it regularly because everything is automated and scripted. For all this to work, as I mentioned, you need to have a proper logging so that you have so that you know what you're doing, that you can verify that everything worked, alerting for the containers, scripting, the configuration outside of the containers, etc. So all those things are captured in the 12-factor application document. It's 12 factors where an application should conform to. Not only important for cloud native, you should have a look at those 12-factor application definition, because it is a general best practice for all your applications. So also your big monolith that you are maintaining yourself, for instance, in your on-premise situation. I talked already about microservices. I want to go a bit deeper on that subject. And microservices are most of the time smaller because they have just focused on one business domain. But don't say that microservices are small by definition. It should not be that a microservice should only contain a few classes, but it should be focused on a business domain. So it can be several megabytes in size, contain a lot of code lines, whatever, but it should be focused on one business domain so that you can have a set of loosely coupled services, and each service is then focused around the business domain. That makes it easier for you when it's loosely coupled to replace one of those smaller microservices with a newer version. Although that will also be a challenge because other microservices are still calling your service, or clients are calling your service. So you need to make sure that you always keep that backwards compatibility aspect of your service, or that you need to place both services, that you need to place both versions of that service online, one old version for your other microservices or your clients. In the meantime, they are not upgraded, and already your new version. So there is not only a maintenance overhead with microservices, because you need to put into production much more services, and that's why that scripting thing and that cloud thing and that cloud native aspect is so important for microservices. If it's not completely automated, don't start with microservices. That's one thing. There is also, besides that maintenance overhead, there is also a communication overhead, because now you do not call another method within that monolith, but you call probably another microservice, which is another JVM, can be another machine, can be maybe another data center. So you have a communication overhead. You have to do the serialization from your native in-memory representation of your object to JSON and back. All those things takes time and makes a microservice per definition slower than a monolith. All these small microservices also put a constraint on your security, because not only your monolith is accessible by one endpoint, but now you have 10, 50, 100 endpoints that you can call, because each microservice comes with an endpoint. And it's not only protecting those endpoints, because if you have a chain of microservices, then your microservice at the end still needs to know who was the original caller. Is he allowed to retrieve the information provided by that microservice? What does need to be returned? Is he a regular user, or is he an admin user that can do more, etc., etc.? So all those things makes microservice a challenge. So it is a good thing in the correct environment for the correct situation. But as I said, it's very strict linked to that cloud native concept, because you need to have those things scripted from beginning to the end, so that, for instance, when you do a commit in your repository, a change of actions is set in motion, and then at the end it comes out that it is in test, because you do not put everything in production immediately, or all the way to the end until production. A few things around the Payara and the Payara platform and how it fits into that cloud and cloud native concepts that we saw. First, we have the Payara server, which is the Jakarta EE full profile compliant implementation. So you can deploy there any application which you can deploy on any Jakarta EE compliant instance, and it will run your application. It will do its job. It is the full-blown platform, so with all the things like remote EGB, SOAPs, JMS queues, whatever you like. The typical application server thing, like you install it, you configure it, and you run your application, but nothing is stopping you to put a Payara server into a Docker container and put that into that cloud concept that we have spoken about. But for those cloud and microservice deployment, we have a specific version of Payara server, which is called Payara Micro. It is smaller because remote EGBs and SOAPs features are removed, because not very useful in most deployments within the cloud environment. So it's smaller, it starts up faster because it's smaller. It is optimized to run in the cloud and in those containers, and it has the Jakarta EE web profile embedded, so not having that remote EGBs, for instance, and also including the MicroProfile specifications, but more on that later. Just a note, Payara server has also the MicroProfile there, but that has another purpose, which I come back to it in a minute. So a few Payara Micro features in general, not specifically related to cloud, but it can be used there. Payara Micro is an executable jar file where you can use the hollow jar or the hollow var features with. The executable jar file means you have just that you can start up your instance with java -jar, and then you point to that Payara Micro jar file. And as a parameter, you specify the var file, and then the instance starts up. It is configured on the fly, and it will run that specific application in that var file. With that executable jar file, you can have an optimal layer in Docker images. You should have a minimal number of layers, and your top layer should not change change for any reason. So only the var file can be put in that top layer. So that's a small layer, not containing your Payara instance. So it is faster updated, faster started. Another thing we have within Payara Micro is the data grid, where you can exchange data between instances. Most of the time, the microservices are stateless, are not keeping any information about your user, but you can share data between those, of course, fixed data, which does not update a lot, like postal codes or city names or whatever. And that data grid is designed so that it can automatically cluster in those cloud environments. The data grid looks like this. So you have one grid spanning multiple instances of Payara Micro and your application, and Payara Micro itself also makes use of that data grid so that you have a common data set which is known throughout the entire environment. Specific Payara Micro options for the cloud is that all of jar deployment. You do not need an install. Like I said, you have that Java -jar option. Installation of your database connection, your database connection pool, for instance, can be done through some kind of initialization file, the postboot command file, where you create that connection pool on the fly when your instance is starting. But we have other specific integrations, for instance, with volumes, with Docker volumes, Kubernetes volumes, so that you can persist some of your data. Because, as you know, a container, when the container is stopped, you lose all your changes. So you need to integrate it with the volumes to have persistent data storage. It's also integrated with Kubernetes secrets, for instance, that you can put there your passwords for your database connection so that it is not available within the image, so that it is better secured. Another thing that we have is the automatic clustering. For instance, the Kubernetes horizontal pod scaler determines that based on the CPU that you need an additional instance. It starts up another container. And due to that data grid automatic clustering, it joins the same data grid which was already available, so it can immediately participate in all the requests and make use of all the data which is gathered and available to all the other instances. So the clustering, the easy clustering is definitely a nice feature and easy to use of Payara Micro feature. Jakarta EE, probably you all know, this is a more general presentation, but this is one of the tech talks of Jakarta EE, so you probably know that it is the new name of Java EE under the Eclipse Foundation. And in general, it is around enterprise Java with a set of specifications and standards. How do you access the database with JPA? How do you receive connections for REST endpoints with YAXRS, etc., etc. So that's the specification, the standards, and you have one API but multiple implementations. Like I said, Payara is one of the compatible implementations, but there are others, of course. And I checked the website and I found out that there are already 8 registered compatible implementations. So you have a lot of things to choose from. It is now also a completely community-driven collaboration, so anyone can help in moving on this this set of specification. Your input about features, about issues that you find, about your help in development, etc., is highly appreciated because it's now entirely community-based thing. A lot of companies are, of course, also involved, but the focus lies now on the community. And the main focus is about the long-term stability. Just as Java EE was something which was backwards compatible for 15 years, the idea is that we also have something for Jakarta EE. We are now doing a breaking change with Jakarta EE 9 due to legal requirements of package names and namespace names, etc. But there will be tools to help you overcome that issue, and from then on, we again strive to have backwards compatibility and long-term stability. Some people say that Jakarta EE is not very important anymore, so the question is that all required? But if you see the list, what is in there, then you see that it is used in a lot of other frameworks and even standalone situations. You have servlets, a lot of frameworks, or when you're dealing with HTTP requests, are using servlets. So that's not only restricted to Jakarta. Same for JAX-RS, the REST endpoints. Again, a lot of things are based on that. Security, always important for your application, and you see all those terms and all those specifications and features from Jakarta EE security coming up in other frameworks also. I mentioned also MicroProfile, which has a little bit of a different focus. It is used for optimizing that enterprise Java way of working for your microservice architecture. It is perfectly possible to create a microservice with Jakarta EE specifications only, but then you're missing a few goodies in that distributed environment because microservices, the focus lies there on a distributed environment, and you all probably know that the distributed environment comes with a few challenges. One of the things is the request. A request can take a lot of time. It can time out. It can fail because there is a network issue. It cannot happen because, for instance, the service at the other microservice is down, etc. So all those scenarios are handled with the fault tolerance specification, where you can do a retry, a default value, a circuit breaker that you not trying to call that microservice over and over again, knowing that it is down, etc., etc. That distributed environment makes it also more difficult to follow the request throughout your application, because it's not only within one JVM, but it now spans 5, 10 calls, remote calls, even with remote REST calls. So with that open tracing specification, you can do what is called a distributed tracing. You can follow all those calls. You can see how much time it spends in a certain microservice. So you can see, for instance, what is the slowest part of your request and what should be tuned maybe. Another thing what I like to say is about that JOT token. I mentioned already that security, that the last microservice needs to know who was making the call and where is the roles and the permissions he had. So with that JOT token support, you can propagate your security context from one service to another, which is, of course, a required thing to have successful implementation. Other things are open API to see how what your endpoints are defined, what the contract of your endpoint is, metrics and health to see the status of your system. Is it operating well? Health is, for instance, used by Kubernetes to shut down a certain microservice and restart again if it is indicated as no longer healthy, etc. Again, a similar thing to Jakarta EE. You have one API, multiple implementations, and you find implementations of the core MicroProfile specifications within Payara Micro, but also within the Payara server, because those specifications can also be useful outside of your microservice environment. You have something like the config specification, so that you can define the configuration external from your application, as I mentioned that you should do. That can also be used, of course, and be very handy in your application, whatever type it is. But as mentioned on the previous slide, I did not say it there, but there are different goals. MicroProfile wants to be more innovative, will do more breaking changes. There is normally a breaking change every year, so that you need to update your code in those cases, and you cannot rely on that backwards compatibility. So That's the theoretical part, I would say. So I give the word to Fabio, who will show you all the things in action.
Okay. Hello, everyone. Thank you, Rudy. I thank you for here. So that's amazing to see here to talk about Payara with cloud. And my question is, how can I make that easier? How can I take my application and move to the cloud? And I'm gonna show to you first. I'd like to create a small application that's gonna run as a Maven project. Yeah, thank you, Rodrigo. As you can see here, I'm gonna use Java 11. Therefore, no Java 8 anymore. I'm using Payara. And basically, what does this application gonna do? Basically, this application is a microservice to hand fish, right? Payara, the Brazilian fish. And basically, we're gonna storage that fish on a NoSQL database. And guess what? A MongoDB, and create a microservice. Why should I choose microservice? Roddy say that very well. But just on this case, let's be a little bit of hipster and create a small product that you're gonna use microservice. Basically, I showed to you it's a Payara, and therefore the MicroProfile gonna be provided. The same thing gonna happen with my Jakarta E API. So it's gonna be provided by Payara. And to integrate my application with MongoDB, that is a NoSQL database, I'm gonna use the Jakarta E specification that handle that to me, that make easier to you as a Java developer to integrate your Java application with a NoSQL database that is Jakarta NoSQL. Basically, as you can see here, I have my mapping API. Think about JPH, NoSQL database, who map into document, and my driver communication. Think about uh, JDBC to MongoDB. And let's move forward. So let's create my first class, and guess what? My fish. And I'm gonna create something. The first one gonna be my ID. Oops, no, the ID, and my name, because I don't have enough time to create more attributes. Based on that, what I'd like to do next, basically I'd like to take my class and convert to MongoDB and vice versa. Basically, I'd like to convert to or from a NoSQL database. To make that easier, Jakarta NoSQL is annotation driven. Therefore, I decided to use annotation to make that possible. In this case, I'd like to define this as an entity. Therefore, I'm gonna put the at entity. I'd like to define as an ID. I have the ID annotation. And beyond that, I'd like to define this attribute to store that on my NoSQL database. Therefore, column. Beyond that, usually on the MongoDB itself, I have one information. This information is my ID. On this case, I'd like to use the object ID. And to make that possible, I don't like to show that to my application. I can use my convert. If you are familiar with JPA, you can see that it looks like JPA, right? So NT ID column converter, object ID converter. So basically, again, it looks like my converters, where I have my string, the attribute that I have here, and my object ID, that is my internal NoSQL database storage, right? I put my ID, I put my column. Just to make that easier, I'm gonna put a lot of get setter. I don't care about it, at least on this presentation. And let's create my equals hash code. Let's define just the ID. And as you can see here, right now I have my equals in my hash code. Yeah, I just have one hash flow here. So basically what I have right now is my entity. The next step is create my repository. So fish repository, and that is interface. If you know Spring Data, it looks like Spring Data. Basically, I have my interface that is fish repository, and then I can extend from repository where I have two generic attributes. The first one is my type. Oh, that's not good anymore. And then my second one is my type. As you can see here, let's show to you. I have the T and the key. So the entity and the key itself. Done. I have my entity in my repository. The last step is my fish repository. Where, oops, no, fish resource. Sorry for that. Fish resource. Where I can basically put my output here. Therefore, I have my path where gonna be fish. I can define the way that I produce. I'd like to produce and consume application JSON. Like copy paste here. Let's find application scoped. Let's create my fish repository. Let inject thank you CDI to make that happy to me. And let's create my small CRUD operation, right? So the first step is return everything. Fish that's gonna get all. I know we have better way to handle that, like my find all, right? And one good point is, as you can see, I don't need to. That's interface. So basically, I just can create my interface here, and I don't care about my implementation itself. I have my find all. For sure, I'd like to have my option to find by ID, where I have my ID here. So basically, what can I do is repository find by ID, where I have my ID. It's gonna return my fish optional. Why? That's an easy way to handle the new pointer exception. If you don't like to handle new pointer exception anymore, the API is built on Java 8 and higher, and you don't need to do that. Basically, on this case, if I don't have my fish, I'd like to return 404. So let's make it happen. Fish OL stro. Let's return my 404. View application, right? Okay, and as you can see here, I have several options that include my not found. Oops, not found option. No. Not found. Here you go. So basically, if I don't find, return to me, please. Not found. Void search where I have my fish. On this case, I'm just gonna save. And the last one gonna be my delete. So void delete repository delete ID. Done. Right now, what you do have, we have the basic operation. So I have my get here. I have my get, but with a path where I have my ID This path parameter is ID as well. My insert is gonna be my post, and for sure my delete is gonna be my delete, so the operation. And let's copy paste here. Let's go paste there. Done. Basically, what I do have right now is my application, right? So what I did, I create my entity, then I create my repository, and then I create my resource. And basically my application is ready to go. One good point, I can run locally. How I did that? I create my configuration from that. If you see here, it looks like JPA, where instead of I put my configuration from the persistent XML, I put that in configuration file where I can put more information. I can overwrite information. I'm gonna show to you later. But basically, I put localhost because I'm gonna run my Docker. As you can see here, a Docker running, and my provider that is a MongoDB configuration, where it's gonna take that configuration and run my application locally. Okay, I'm gonna show that. Basically, I'm gonna put this command to run. Okay, so don't worry, I'm gonna show that later. So it's gonna run my application, and to run, it's building my application to run. I'm gonna put the java/jar target MicroProfile microbundle, and that is it. That's the whole environment to make that happen. Basically, what I did was take my application and run locally. My next question is, how can I move that to run in the cloud, right? Because to test is amazing, but however, I'd like to put that in the cloud. So it's a deploy it. Let's do a send something. It is starting. Is get the Mongo driver, and there's no information for sure. And the whole point here is, okay, I have an amazing, everything's working. Oh, no, that's not working because I don't have my application run, my MongoDB running. Oops, not you. Finally, we have the MongoDB running, and as you can see here, basically I can put some information. But that's not enough, right? So I'd like to move that to the cloud. And that's we have Platformsh as a Service. Platformsh as a Service is an easy way to take your application and move to the cloud easily. It's also, if you can take a look here, it's a cloud native solution. There are much more than just Kubernetes, so that we have several solutions. And basically, to make possible with Platformsh, I have 3 configuration files that I'm going to show. But basically, I have one to define how can I build my application and put that in container. One to define the service that I want to. On this case, I have MongoDB, that version, and the how to run that application. I push that remotely. That is my same application. I just need to push to my master, and guess what? It's gonna be to me my same application app, my app container, my MongoDB container, and my host container, where I can define where should I go. And okay, let's show to you. I guess everybody here knows that cloud is amazing, right? There's no question about that. My whole point is there is a huge risk to use cloud. There are several ways to use cloud. There are several stuff to use clouds. And when you decide to do everything by your home hand, by your bare hand, that is a complexity, and complexity also means risk. I guess we saw a lot about how Kubernetes is amazing. Yeah, that's true. However, nobody tell you how can I do backup of my information using Kubernetes. How can I maintain my container in the Kubernetes, right? The whole point here is everything in the software architecture, there is a trade-off. And when you decide to take everything you do by your bare hand, that is a huge complexity. And beyond that, because that, there is a risk. As I mentioned before, cloud, there is a huge complexity. And that's why we have Platformsh. The whole idea of Platformsh is to make easier to take your application and move to the cloud easily. On this case, for sure, we love Payara. Why not take your Payara application and move to the cloud? The whole idea here is basically, okay, we are much more than a hosting. We have several language support, and we have support to several architecture solution. Therefore, if you have microservice, if you have monolith, if you have stateful, if you have stateless application, we can handle the whole complexity to you. To make that happen, as I mentioned before, we are using the infrastructure as a code approach. Basically, to make that possible, we have 3 files that I'm going to show to you. And based on 3 files, you push the code on your remote repository, and Platformsh is going to build to you. The first one is my application YAML file. As you can see here, this looks like my application to define, where I have my name, I have my type. As you can see here, that's a Java type where I can put more language. We have more language to support. And here, for sure, there's the version. Okay, I'm using Java 8. Don't worry, you can downgrade to use Java 8. And if you'd like to test Java 11, you can create a branch, set as Java 11, push this branch. Platformsh can deploy your application to Java 11. You can do some tests. If you agree what you have, just merge to the master or the main branch, and Platformsh is gonna build automatically to you. Okay, that's the version. Build is how your application gonna build. On this case, it's running Maven clean package. The relationship, think about security. Basically, I'm saying that this application needs access to a database that is a PostgreSQL. Because when you talk about cloud, you need to think about security. We need to make sure the right application has access to the right database. For example, I need to make sure that my marketing application does not have access to financial database. On the Microsoft Edge, we need to make sure the right service has access to the right service. And that's why we have the relationship, to make sure the right application has the right access, the right client. And the last one is the command to I run my application. As I mentioned before, and as Rude mentioned before, if you are using MicroProfile configuration, you can overwrite the whole configuration. That means your developer does not need to know the environment, the password, the user from production. And that's the right way, right? That's why we believe in the 12-factor application. Again, the type, the name, the type, Java, the version, the command to run, and the command to start. The command to build, sorry, and the command to start my application. And for sure, my credentials, because security is important. The second file is my service file, where I can put what I want to. On this case, I can put several services such as relational database, think about MySQL, PostgreSQL, MariaDB, NoSQL database, you can think about MongoDB, SolarSearch, Elasticsearch, Redis, and so on. And the last one in my route. Basically, you can define each application gonna have public access. Yes, if you want to, you can have a bunch of microservices with just one with public access. Again, security is really, really important to us, right? When you think about cloud. And it works like a magic. You create this code, it's a Git native, you push your branch remotely, and Platformsh is gonna build everything to you. You can merge like this one here. I have one feature I can merge to the master, and it's gonna automatically build to me. And you can do deploy every time, anytime, even Friday. Also anywhere, right? Because Platformsh has 25 regions. We have several hosts. We have several storage core processor. Remember, as Root said, Platformsh is a platform as a service. Therefore, we need an infrastructure as a service. You can build and run with Amazon AWS, Microsoft Azure, Google Cloud, Orange, and much more. And that's the whole overview of Platformsh. So my containers from that application file, my service that I have available, and you have several infrastructure as options. Yeah, that's a Git native, and if you wish, you can integrate with GitHub, GitLab, and Bitbucket. You don't need to worry about Docker, Kubernetes anymore. Platformsh is gonna handle that to you. And security, security, and security. My whole point here is you can make your application go to the cloud easily, use this kind of solution. And for sure, we have several clients. We have over 1,000 clients to make that possible. We have some famous clients that you might know, the Economist, the Unity. Yes, I already did my demo because I love do live code, but that is my whole point here. If you want, you can take a look here. That's my sample application that I built, and with just one click you can also deploy this application in the cloud with Platformsh. So sample code, I can pick the region here, so let's take this region here, and done. So basically it's gonna build my application with my whole environment. Okay, it's building, but that's it. That's the result. Okay, it's gonna build my application, and we are almost over time. So okay, it's built, and it starts with master. And as you can see, I have my host, my app, and my MongoDB application. We have support to several environments, several Java applications. And thank you. If you have any question, let me know. If you'd like to know more, we have an amazing book that we with Payara did. That was amazing. There you can learn about cloud native, and how you can integrate Payara with Platformsh. So go to this QR code and take a look on this amazing book that's for free. Is there any question to us?
We do have one question. It says, how do you scale your apps with Platformsh?
Yes, you can scale your application. You can define a load balancer, and you also, if you want to, you can put more power in your instance mode. Therefore, you have two ways. You can scale vertically and horizontally. That's how you want to. That's possible as well.
Okay, did that answer your question, Rodrigo?
Okay, is there any more question? Please, guys, raise your question.
Oh,
Auto scale is done on Platformsh? No yet. We are working on that. Hopefully, we're gonna have that soon. So you need to define, use the concept of infrastructure as a code to handle that. You're welcome.
okay. If there are no other questions, then I guess we can wrap it up there. Thank you so much, Rudy and Otavio, for your presentations today. To anybody who wants to watch the replays of these, you'll be able to see the presentation again here on the same link, as well as on the Jakarta EE YouTube channel. Thank you, everyone, for coming. And again, thank you to our presenters.
Bye.
Thank you for joining. Bye.
Great day.
Good day.